Hi, Intermediate Algebra. Happy Wednesday. I hope everybody's well. And I just wanted to say what a bunch of troopers you guys are for getting through this. I just feel like everybody's been, on task and just changing to this new format and getting it done and getting your tests in. And I'm so happy to say that we're almost there. We have really jumped this fence and we're about to finish up now, and it's been quite a ride, and I just appreciate how great you guys have all been, and I'm just sort of inspired how you guys have just been able to shift gears and get it done this way, because this is quite a big change for you, for me. This is something. Okay, so I'm gonna roll with 10.7 today, so that's quadratic and rational inequalities. And so basically what we're trying to do is we're trying to figure out what values of x make this parabola less than or equal to 0. So it's basically asking what domain puts the parabola at the x-axis or lower. And once I solve this, I'm going to go back and say that again because it sounds really abstract right now, but I just wanted to sort of plant that seed. So I'm going to go ahead and solve this, and then I'm going to go back and show you what this means. So when you solve a quadratic inequality, you want to first set it equal to 0. And once it's set equal, well, you know what I mean, like just get 0 on one side. It's not really set equal because it's an inequality. But get 0 on one side, and then the next step I want you to do is I want you to factor it. And I know this is going to sound really weird, but I temporarily want you to pretend that this equals to 0. So I want you to pretend for a moment that this equals to 0. And when that equals to 0, that's what we're going to call the critical numbers. Okay, so I'm going to pretend for a minute this equals to 0, and if this equals to 0, then x is going to be 1 and negative 5. Okay, if this is equal to 0, x is going to be 1 and negative 5. I want you to take those numbers and I want you to put them on a number line. Okay, so these critical numbers will separate the number line between where the function is positive and where the function is negative. I know that sounds weird, but that's the idea. The critical numbers will change where the function is positive and negative. So if the function changes from positive to negative, it's going to change at these special values, because this is where you're on the x-axis. You're on the x-axis at these points, and either after that you're going to be above or below it. All right, now another real important thing, and one thing about mathematics is it's sort of like there's little details you got to watch for. Since this has the bar right here, these have to be closed, okay? Because it's allowed to equal to 0, okay? And it's going to equal to 0 at negative 5 and 1. If there was no bar here, then these would be open circles, okay? So if there's a bar, make them closed. If there's no bar, make them open. All right, so this has the bar, so I'm making them closed. Now what you're going to do, and I know this section's a little oddball, a little weird looking, but what I want you to do is find what we call a test value. And a test value is any number that falls in the segment. Any number that falls in the segment. Like this segment goes from negative infinity to negative 5. So I could pick something like negative 6 because that falls in that segment. I could pick negative 7, negative 8. So anything that falls in this segment, just do not, as a test value, never ever pick a critical number. Okay, stay off of that. Think of this as like separating or like a barrier. Don't ever pick the barrier. Don't pick the barrier. Stay to the left or right of it. Now for this segment here that's in between negative 5 and 1, I can pick anything in between here. So I'm picking 0 for a test value, but I could pick negative 1, negative 2, negative 3, negative 4. I could even pick fractions. Like there's actually an infinite amount of numbers in here if we go into decimals and fractions and all that stuff. Now over here, I'm gonna pick something greater than 1. So anything greater than 1 to infinity, I'm gonna pick 2. So I'm just gonna make a suggestion here. It will mathematically crunch out easier for you if you stay near the critical numbers. Like I could pick 100, but it's sort of a headache for me to solve that, but it's doable. Unless you're sort of doing it abstractly, then you can do 100 because you just really want to know if it's positive or negative. All right, you take these test values and you can plug them into the original or into the factored form. Now, it just depends what your brain thinks is easier. So my brain always, most of the time, thinks the factored form is easier, but for some people, this is easier. And one thing about learning is you want to trust yourself, and like what works better for you, it truly works better for you. So if your brain is saying, oh, I like this format better, then please use this. Don't use this just because I like this. They're both correct. So whichever way you're doing it, you're going to take the test value and you're going to plug it in. So I'm going to plug it into the bottom one. Okay, let me just make sure I can see here. Okay, so my test value, I'm letting x be -6. So it's my first test value. So I'm doing -6 minus 1, -6 plus 5, and I'm trying to see if this is true or false. -6 minus 1 is -7, -6 plus 5 is -1. So I'm getting 7 is less than or equal to 0, which is false. Okay, that's false, which means that the values in this segment do not